Hi everyone. Today's lesson is on the areas of composite figures. And although this is not in our textbook, it fits in nicely with the area unit that we're working on and would be roughly in chapter 11 if I had to give it a section number. So our objective is going to be to find the areas of these composite figures. So first of all, here are some examples of composite figures. So before I give you the definition, just take a look at these four and make a guess about what you think a composite figure is. Alright, so the definition of a composite figure is a figure that can be separated into regions that are basic plane figures. Think of parallelograms, triangles, trapezoids, rectangles, circles, etc. So the figure that you see at the right started off like this, and I was able to divide it into a square and two triangles. Now, you can turn a composite figure into a lot of different shapes. So although I did go a square and two triangles, I could have also said that this composite figure is a trapezoid, ABEF, and a triangle. And often there are a lot of different ways to split these composite figures into these basic plane figures that we are more familiar with. Alright, so now to find the area of a composite figure, the key is to divide and or split it up into different regions and find the area of each region. Then what we're going to do is add all of these areas up together. We're going to find the sum of the areas. So we're going to give that a shot on the first example here. But quick review, these are all the area formulas that you're going to need. So just go ahead and pause the video and write them down all in one place, or if you already have these written down, just make sure you know where they're at and where to refer to them. So we've got the rectangle, parallelogram. Remember, these are the same formulas here. We have the triangle. We have a trapezoid. On the next slide, I have our rhombus and kite formula for area, our regular polygon formula, our circle area formula, and I'm going to make a new addition. I'm going to write the area of a semicircle, and we're just going to put a 1/2 in front of pi r squared. So just write that down if you haven't already, and keep these in a safe place so you can refer to them, because you're going to need most of these formulas for our lesson today. Alright, so here's our first example. Find the area of this composite figure below, round to the nearest hundredth if necessary. So I'm going to show you a couple of ways you can do this. So one possible way is to draw a line, a vertical line right here that separates this triangle from this rectangle. And notice how this is a 4. So I have number 4 here, and I was able to determine that that was 4 by taking that 6, that distance of 6, and just subtracting from that distance of 10. And that tells me that this portion is 4. And likewise, going this way horizontally, if this portion is 5, and if I take 12 minus 5, I will reason that this is 7. So use parallel segments to help you find missing side lengths. And as you can see here, the area of this rectangle, this portion here, is just 10 times 5. So now I take 10 times 5, and that gets me 50. Now I want to get the area of this triangle as well. So here I'm going to use 1/2 base times height. So remember, the base and height of a triangle come from those two dimensions that create a right angle. So it doesn't really matter what this is, because our base and our height come from here. So 1/2 7 times 4 is going to be 14. Alright, so now remember, you're going to add these areas up once you're done. So you take the 50 square inches from this rectangle and the 14 from the triangle, and you're just going to add those two up, and you're going to get 64. Don't forget your units. 64 square inches is our final answer. Here is an alternative way you can do this. Could have also drew our line here horizontally and divided this figure into a rectangle and a trapezoid. As you can see, if we would have done it this way, we would have gotten a 30 for the rectangle and 34 for the trapezoid, which after you sum that up would give you 64. So you can use vertical or horizontal lines. I would stay away from diagonal lines. Those are much more tricky to use. Just draw lines that are parallel to existing lines, and that way you're able to easily find missing dimensions. Alright, so here is a problem that I would like for you to try out. Please pause the video and give it a shot and check back when you are ready. Alright, so here what you can do is draw your line right here horizontally, and what you can do is divide this shape into one rectangle and one triangle. You could consider that you can consider that two triangles if you like, but that's extra work. So as far as a rectangle, we have a 10 by 8 rectangle here. Don't use 12 because 12 applies to the entire height of this composite figure. So we have 10 here times 8. So 10 times 8 gives you 80, and that's the area of this rectangular portion. Now for the triangle, you think of this, your 10 as your base, and the height is 4. So how do we get 4? We took 12 minus 8, which means that this vertical height here must be 4. So 80 plus 20 gives you 100 square feet. Now if you treat this as two triangles, you would end up getting 10 units for each triangle, which would still give you 20. So our final answer again is 100 square feet. Now you can also separate this figure into two trapezoids. So here is the solution if you'd like to try it that way, or if you did try it that way. Notice you'll still get 100. Two trapezoids with an area of 50 square feet each gives you 100 square feet. Alright, so let's move on here to example 2. So we're going to find the area of this composite figure. So notice we've got a round portion up here. It doesn't look like a complete circle, but it looks like a semicircle. And looks like we've got a trapezoidal region down here. So I am going to add our horizontal line right there, which should hopefully make that a little more clear. So it does look like indeed we have a semicircle at the top and a trapezoid at the bottom. So let's find the area of that trapezoid. So if the distance from end to end here is 6, that means that one of the bases of the trapezoid will also be 6. So in our trapezoid calculation, notice I add 10 and 6. It doesn't matter what's base 1 or base 2, as long as you add those two measurements up. And the height is 8 because they are giving you the perpendicular distance here. So it looks like there is a right angle made right here. So that's our height, and when we add these up, multiply by 8, divide by 2, we should end up with 64. Alright, now the semicircle. So the area of a semicircle, again, it's the area of a circle just divided by 2 or taken in half. So our radius here is 3. Okay, be careful because the radius is from the center of the circle to a point outside the circle. So it's not 6. So be very careful with that. So our radius is 3. So we're going to write 1/2 pi times r squared. And if you calculate that correctly, you should get 14.137. And for our total area, I'm going to add 64 plus 14.14. to give us an area of 78.14 square centimeters. All right, so please, again, pause the video, try this problem out, and check back for the solution when you're ready. All right, so here notice we've got this rectangular portion right here, and it looks like we have another semicircle at the edge here. There isn't one on this side, it's just one semicircle here. So what you want to do is, my animation didn't work here, but there we go. So we're going to divide this into a rectangle and a semicircle. And notice for the rectangle, you're going to go base times height. 30 times 16 is 480. For your semicircle, remember it's not 16, but our radius is 8. So 1/2 pi times 8 squared will be 1/2 times 64 pi, which is about 32 pi. And our answer is 100.53096. So again, try not to round too early, as we've talked about before. But our total area here is going to be the 480 from this rectangle. So this area here is 480. And then the area from that semicircle, which is 100.53. And again, add those up, and you should end up with approximately 580.53 square feet. All right, one last example here. So we're going to find the area of this composite figure shown here. Now, the vertical lines are already drawn in here, but on your homework, you may not see those there. But this kind of reminds me of the track problem that we talked about a few weeks ago, where you're running around a track, but we're not interested in the perimeter this time. We are interested in the area of this figure below. So notice we do have a rectangular portion, and we have two semicircles. All right, so for a rectangle, that's an easy calculation. Base times height. Here I wrote 15 times 25. Again, technically this would probably be our base here, 25, and our height would be 15. But it doesn't really make too much of a difference because you're just going to multiply those two numbers anyway, and you get 375. Now, for the two semicircles, so remember, area tells you how much square units a shape takes up. Another way to think about that is how much space a shape takes up. So when you think about it, the area of two semicircles takes up the same amount of space as a full circle. So I can go ahead and just use the area of one circle to figure out the area of these two semicircles. Important thing is I just need to remember that that the radius is 7.5. Okay, just be very careful with that. Radius is 7.5. So pi times 7.5 squared. Do not take half of this. If you do, multiply it by 2, which will, and you'll end up right back here, 176.71459 approximately. Add that up to the 375, and your final answer will be about 551.71 square feet. All right, so that's it for today. If you have any questions, please send me an email or a message on Schoology or Google Classroom. Have a great day, everyone. Take care.